to my channel. So in this video I'm going to try to solve this problem, do some live coding work. At the same time, I'm going to follow the general steps we should follow in a coding interview while trying to solve this problem. So first of all, let's read through this problem. Minimum cost for tickets. In a country popular for train travel, you have planned some train traveling 1 year in advance. So the days of the year that you will travel is given as an array days. Each day is an integer from 1 to 365. So the train tickets are sold in 3 different ways: 1 day pass, 7 day pass, or 30 day pass with the corresponding cost. So the passes allow that many days of the consecutive travel. For example, if we get 7 day pass on day 2, then we are going to be able to travel from day 2 to day 8. So return the minimum number of the dollars we need to travel every day in the given list of the days. So let's say we have the list of the days something like this. The cost for 7 day, the cost for 1 day, 7 day, and 30 day pass are 2, 7, and 15 respectively. So the output is going to be 11, which is the minimum cost for us to travel for the days in this list. So it's pretty clear. Let's see the constraints. So the constraint says the days is each of the days anywhere between 1 to 365. The length of the list, length of the days list is anywhere between 1 to 365, which means we are not going to be given any empty list, so that makes sense. So days are in increasing order strictly, so it seems like not too much of the room to think about some edge case for the day's input, and also there's no illegal input for cost array. So having said that, I think not too much of the room to think about the edge case, pretty regular. In our case, I think we should be good to go for the next step. So for the next step is to find the approach. So how to solve this problem. So let's see how to solve this problem. So in my mind, I think of course we could do some recursion to try to enumerate all the possibilities and get the minimum cost within all the possibilities, but actually we could do better. So usually for some problem asking about the best solution, the best like for example in this case is like the minimum cost for tickets. Usually we could try to think in a way like if we can solve the problem in DP, in dynamic programming. So for dynamic programming, the core is the DP formula. So let's try to think about how we are going to solve this problem. So for DP, first of all, we need to define the subproblem and the corresponding solution to the subproblem. So let's say we have like a 1D array. Let's call it DP. So the 1D array for DPI, it means the minimum cost to be able to travel between days 1 to I. So when I say the minimum cost to be able to travel between days 1 to I, it's actually based on the input for the days. So for example, let's say DP, let's say I is equal to 10, and in the given input we only have 2 and 8. So we don't actually need to travel on day 1 or day 3 or day 7, something like that. So to be exact, it's something like minimum cost to be able to travel minimum cost to be able to travel at the end of day I. So that I think that would be like a more exact description about this DP array. So the next step is about to find the DP formula. So how to do that? So let's say how to compute the DP I plus 1 from the previous computation. So let's say suppose there are two different cases. One is we don't need to travel on dpi plus 1. So in this case, it would be so dpi plus 1. So if we don't need to travel on day I plus 1, then we just have dpi plus 1 as dpi, because essentially we don't need to do anything. Otherwise, if we definitely need to travel on dpi plus 1, what we could do is we could have 3 different choices, whether we have the 1-day pass, 7-day pass, or the 30-day pass. So it would be something like the minimum among dpi plus cost 0. So this means we are going to buy a 1-day pass for day I plus 1. And another case is we could do dpi minus 7. This would be dpi plus 1. We are computing dpi plus 1. So this would be dpi plus 1 minus 7, which is I minus 6, plus cost 1. Which means we are going to buy a 7-day pass on day I minus 6. Okay. And another thing is we could do like a dp. So let's say if it is I minus 6. So if we are computing the dpi plus 1, let's say we buy a pass on my I minus 5. Let's say I minus 5 could be usable until I minus 7, I plus 7, right? So this is minus 5. Yes, so okay. I think it's right. And the other thing is we could do like a 30-day pass. So the 30-day pass, which we are going to be I minus 1, so I plus 1 minus 30. So we have these 3 different choices, whether we do 1-day pass, 7-day pass, or 30-day pass. So it's something like this. So having said that, the runtime is, so based on the constraints, it says the length of the days is anywhere between 1 to 365. So this means we are actually looking at a linear solution just based on this, because maybe it's not linear, it's more like a O1 solution, because this one is actually constant, like the max length of the days, input days array. So if we have like we want to be more exact, I think let's say if we have it's actually not based on the days. We need to definitely go over from 0 to 365. Okay, so I think it's still all of 1. That's because we have like a constant and a while for loop. So I will explain more why it is constant. So currently, let's do some coding on this solution at this time. First of all, we are going to define the DP array. Let's say we define the DP array as int 366. That's because we have the day 0. So the day 0 is 0, which is essentially nothing, just for us to for the easiness of our computation. So the next thing is we are going to go over I from 1, I smaller equal to I would say this is 365 and plus plus I. So how to compute the DPI? So we are going to say, or maybe we just don't define this one as DPI plus 1. Just instead we will have like as DPI. This will save us some this will align our code with this formula. So let's see. DP, so this one we definitely need to see if this day is within the days. So how to see that? So we could actually turn this into a hash set. So that would be easy for us to take a look. Or otherwise, we could have like an iterator on top of the index within the days array to see it. But let's see. So for the easiness, I would just turn this into a hash set. So I'll define a helper function. Let's say this one is going to return a set of the integers. AR2 set. We have the days, teacher. We go over each of the days. Day set. Okay, day set. Don't add the day. And then we just return day set. Alright, so set of the integer day set is equal to days. Okay. Alright, so if day set dot contains I, this would be the else branch actually. So I will say this one. So if the day set doesn't contain I, this is the if branch. Then we are going to do days I just as equal to days. DPI plus 1. DPI is equal to DPI minus 1. So otherwise, what we are going to do is we are going to use this one, which is the minimum stuff. So for this case, actually, let's say we have the DPI initialized as a maximum integer. So DPI is, or maybe we don't need to do that. So let's say DPI is actually initialized as DPI minus 1 plus costs 0. And then DPI is mass.min between DPI and DPI minus 7 plus cost 1. Okay, or this could be so actually I minus 7 could be smaller than 0, so we use something like max of between I minus 7 and 0. Okay, then the next thing we could have is I minus 30 and plus cost 2. Alright, and at the end, what we need to return is we are going to return DP days. This would be days.length minus 1. So it seems like we have pretty much everything. I'll just rely on this platform to help us do the debugging work or do the testing work. Okay, some compiling arrow. We have so this is min costs, some typo here. Okay, so let's do, okay, so for the first test case it seems to be okay. Let's do the rest of them. Alright, it seems to be fine. Let's do a submission on this piece of code. Okay, so it seems like we are in good shape for this question. So that's pretty much it for this solution. If you have any question regarding the solution or regarding the code, feel free to leave some comments below. If you like this video, please help subscribe to this channel. I'll see you next time. Thanks for watching.